Hi guys, and welcome back to laptop repair case study. So today here we received an HP laptop for repair. So this laptop doesn't turn on, so we received this laptop from a customer. So the customer has already taken to another repair shop, and the previous repairman declared that the laptop cannot be repaired and the customer need to replace his motherboard. So they brought this to our shop here, so let us see whether we can fix this today for the customer. Okay, so look at the ampere reading of the DC power supply. Now I'm going to connect the adapter. So let's watch the ampere reading. Yes, I have connected. So the ampere reading is around 1 milliamp. So there's no much improvement in the ampere reading. Okay, let's turn it open, pressing the power button. No response. So let me see the adapter light. So usually we have adapter light for HP laptops, and we don't have the adapter light. So you can see we don't have the adapter light. Yes, so most probably in this case the LDO voltage inside the laptop is not present, I think. So anyhow, we can open the laptop, disassemble the laptop and take out the motherboard, then we can check it. Okay, so the board is out. So I can remember this type of motherboard. So we repaired a laptop which had this type of motherboard, which had a problem with the EC firmware that was corrupted, and after flashing the firmware and replacing the charger IC, and the laptop came back to life. So, and I can spot here immediately, so this charger IC is missing on this motherboard here. So let's just replace the charger IC. So I don't want to plug in the adapter right now because important component is missing on this motherboard, which is the charger IC here. And we should not always inject power or plug in the adapter if a regulator is missing on that motherboard. And if you have the upper and lower MOSFET on that motherboard, if the regulator is missing, at any time your upper MOSFET can get shorted and 19 volt can pass to the load. So you must be very careful in doing that. So if I turn it on the other side, yes, so here we have the upper and lower MOSFET of the charging section that goes back to this battery connector here. So now if you plug in the adapter and we don't have the charger IC here, I think most probably we may not have the 19 volt rail, so that is not a problem. So the upper and lower MOSFET will not get shorted because there won't be any power rail on the DC jack here, on the main power rail. So that is not a problem. But for example, if the standby IC is missing, and if we have the upper and lower MOSFET of the standby section, and at that time if you plug in the adapter, at any time your upper and lower MOSFET can get shorted and 19 volt will straightly go through the load and it can damage the loads. Okay, so we must be very careful in doing that. So most probably this charger IC should be BQ24725A. So let us open the schematic so that we can confirm the model of the charger IC and we can replace it here. Then we can go for a check. So there's no point of checking the voltage right now on this motherboard because we may not have we will not have the main power rail in this motherboard due to the charger IC is missing on this motherboard here. Okay, so this is the schematics of this motherboard here. So let me go to the charger IC section, So let me search BQ24. Okay, yes. So this is the charger IC here. So this charger IC is BQ24738. So unfortunately I don't have this charger IC with me, but I have 24725A. So 725A. So basically both of these charger ICs are same, so you can replace it interchangeably. So let me show you that here. So this is BQ24725A charger IC, and on this side here we have BQ738. And if you look at the pin outs, so on pin number 20 they both receive the supply voltage, and also on pin number 14 the ground, and pin number 15 we have the low drive output, and pin number 16 the RGN output. And also you can look at the AC drive AC OK pin on pin number 4 and 5, and all of the pins are matching to each other. So you can replace it interchangeably both of this charger IC in any motherboards. Okay, so let me install the BQ24725A instead of this one on this motherboard here, and let's check whether this is working fine. I'm sure it should be working because I have installed on many motherboards and it never returned back, so they are working fine. So let me replace it now and see whether this is working here. Okay, so before replacing the charger IC, I need to check the impedance on all inductors on this motherboard here, especially on the CPU coil. And we should not find very low impedance at the CPU coil here, otherwise there is no point of replacing the charger IC if we have a low impedance on the CPU coil here. Okay, so let me check it with regard to the ground. Yes, so 50 is okay for the CPU coil, that is fine. This one is 188, okay. 129, most probably this is the RAM coil, so that is fine. 155, okay. 155, okay. On this one here, battery coil, and this is fine. So there is no direct short on the inductors, so now it is safe to replace the charger IC and we can go for a checkup then. Okay. Okay, so now I have replaced the charger IC here and it looks fine. So before connecting the adapter, let me check whether we have any short on the main power rail itself. So on this side here we have an electrolytic capacitor. So you can see it is 25 volts, so which means it filters the main power rail. So we can check on this side, which is the positive side, which is connected to the main power rail. So let me check the impedance on that point. And we have, yes, so 2.1, so it is high impedance, so that is fine. So no short on the main power rail. Now it is safe to connect the adapter. So look at the ampere reading on the DC power supply. Let me connect it. Yes, so you can see it is now around 13 milliamps, but we don't have the light on the charger. So this one is similar to the laptop we repaired before. which has the problem with the EC firmware, and on that case also we had no light on the adapter here. So I think the case is similar to that. So anyhow, just let me try to trigger the power button and see whether we are getting any response. Okay. So let me short one of these pins to ground through the multimeter. Yes, so when I touch this one, the ampere reading is changing. Okay, now let me check which one is the power button signal. So the pin which is the power button pin, so we can just directly short that one. So let me search it on the schematics. Pin number 6 is the power button signal to the I/O, so we can just short pin number 5 and pin number 6 together. Yes, I'm shorting that, but there's no response. So let me check whether we have a main power rail first. I'm sure we should have main power rail. Let me check it. Yes, we have 19.52, that is fine. And this is the first MOSFET, and the second MOSFET on this side here, the old one, 19 volt. Gate we have 25 volts, so this is an N-channel MOSFET. So the main primary line MOSFETs are all okay, and we have the main power rail in this motherboard here. So now we have to deal with the signal levels of testing in this motherboard. So we can start with the SIO in this motherboard here, and we can go straightly to entire motherboard here. So I think in this motherboard also the problem will be with the EC firmware, because we don't have the adapter light on this connector here. So if the EC firmware has failed, then the adapter light won't glow, because the EC may not configure its pins for specific purpose. So on that case, the EC will not release the the adapter indication signal on this connector here. Okay, right. So let's check the EC chip here and check its requirements in order to output the adapter light here. Okay, so now I have just connected a jumper wire from the power button and connected to a button here, so that I can press it and check the voltage in this motherboard here. So first we can check the EC chip requirements, such as the reassembly set. That is very, very crucial to understand whether the EC firmware is okay inside the EC chip. Right, so connecting the adapter, look at the ampere reading. Yes, 10 milliamps, and pressing the power button. Yes, goes to 60 milliamps, then back to 5 milliamps. Okay, that is fine. So the board is trying to start. So when I press the power button, the board is trying to do something. So, and we don't have the adapter light still. Okay, so this problem is actually different. So let me check the RSM reset, that is on pin number 95 of the EC chip. Yes, so this is 96 and this is 95. Okay, right, and we have 3.3 volts, so the RSM reset is proper. So I'm sure the EC firmware almost okay. So when I press the power button, let me check any voltages on the inductors. Okay, so RAM voltage. So actually the board is trying to restart several times. If you see that the board is trying to turn on, it is going to 60 milliamps, then back to 5 milliamps, and it is recycling, right? and I'm getting the RAM voltage, I guess. Yes, so the RAM voltage is present for 1 second, then it is going off, then it is coming back to the position. Yes, 3.3 volt is there, 5 volt is there. Okay, what about PCH power? Yes, 1.05 volt also there. Okay, CPU power. Yes, we are getting the CPU power also 1.5 volt or something. Okay, what about this one? Yes, so we are getting 3.3 volt at the BIOS pin number 1, which is the chip select pin. So where would be the problem? So I'm sure the PCH or the PCH inside this SoC is working fine, and it is releasing the S4 and S3 signal to high logic in order to release the RAM voltage and also the CPU and the PCH voltage. So something is on this motherboard is having a problem, and we need to find that. And why does the board keeps restarting again and again? Okay, right. So basically, if the board restarts again and again, or if the board turns off after 1 or 2 seconds, we can find that the fault would be mostly on the run power sections, such as on the run power load switches and something like that. So let me just find the impedance value on the load switches, such as 3 volt and 5 volt in this motherboard here. So let me find the MOSFETs that switches the always power to the run power, and we can check whether we are getting any voltage or if there's any low impedance on that point. So on that case also, the board may behave like this way, like restarting again and again. Okay, so let me go to the schematic so that we can find where would be the load switches. Okay, so these are the load switches that is installed in this motherboard. So you can see they are using dedicated MOSFETs to switch always voltage to run power. So on this side here we have 3 volt always voltage, and this will switch to 3 volt run power. So we need to check PQ45 whether we are getting 3 volt on this side here. And also on this side here we have 3 volt always voltage that will switch to 3 volt suspend power, and we need to check whether we are getting 3 volt suspend power or 3.3 volt voltage on this side on PQ46. And on this side here we have another 3 volt always voltage, and this will be switched to 3 volt LAN power, and this will go straightly to the LAN IC. And we need to check whether we are getting 3.3 volt when the board got triggered. And on this side here we have 5 volt always voltage, and this will be switched to 5 volt run power, and we need to check whether we are getting 5 volt on PQ47. And finally on this side here we have PQ42, and this will switch 1.05 volt to this voltage here. Okay, so all of these are N-channel MOSFET. So in order to drive the N-channel MOSFET according to the voltage between gate to source formula, we need to provide a higher gate voltage with respect to source voltage. For example, if you look at this MOSFET here, so you can see the arrow direction is towards the gate, so this is an N-channel MOSFET. And basically the diode direction of the N-channel MOSFET is from source to drain. So this side is source and this side is drain. So in order to get 5 volt output on the source point, we need to provide a higher voltage with respect to source, like greater than 5 volt, like 12 volt or 24 volt, something like that. And if you provide this type of voltage on the gate point, you will get 5 volt output, or the exact voltage as it is on the drain point. Okay, so we need to provide a higher voltage on each of these MOSFETs in order to get the output voltage as it is on the drain point. So this controller IC will provide that higher voltage to each of these MOSFETs. So if you look at on this side, here we have different kinds of on signals, with respect to this on signal, it will drive all of the drivers. So on 1 will go straightly to the driver 1, and it will provide, the driver 1 will provide the higher voltage for the MOSFET to switch the LAN IC, to switch the LAN power. And also on this side, the on 1 will go straightly to driver 2, on 3 will go to driver 3, and on 4 will go to driver 4. And when these signals are present, all of these drivers will be active and will send a higher voltage. So on this side, on pin number 13, there is a dedicated 12 volt output. If you want, you can use it for some other purpose to drive any MOSFETs. So externally you can use this for some other purpose. And also we need to check whether we are getting an input voltage for this IC. So that is on pin number 20. So it will be around the adapter voltage or the main power rail, which is 19.5 volt. After this 22 ohms, we should get 19.5 volt. Okay. So you can look at the data sheet of this IC as well, so you will get a good understanding of this one. Okay, so this is the data sheet of this IC. You can see G5934, and it's a high voltage 1.5 times charge pump with load switch controller. So this is a high voltage switched capacitor charge pump that provides the regulated output voltage of 1.5 times the input voltage. So this IC uses capacitors to provide a high voltage using switching function, and also it provides 1.5 times the input voltage. For example, if you provide 19.5 volt from the adapter as a supply to this IC, it will multiply. So it will multiply 19.5 times 1.5, then we will get around 29 volt. Then if we provide 12 volt, then we will get 1.5 times, then 18 voltage as a V output voltage. So the input voltage ranging from 8 to 24 volt can be converted into 12 volt or to 36 volt. So it depends on the voltage we provide as an input into this IC. So, and this IC has an open drain internal MOSFET output function. So if the voltage output, so V output, is greater than 1.5 times the V in voltage, and it should be around 90%. So 1.5 times the V in voltage times 0.9, which is the 90%, and it should met in order for the internal MOSFET to release the pin here, so the open drain output. If there's a problem on this configuration, then the internal MOSFET will pull the power good to low, and we will get a power bad signal. Okay, so we need to check the V output voltage, that is on pin number 17, and we need to get around 29 volt if you provide 19.5 volt at the input pin here. And also we need to check other pins as well and see whether they are working fine. Okay, so this is the control IC that controls these load switches, which is the load MOSFETs, and we need to check whether we are getting a gate voltage on these MOSFETs and the output voltage on the source point, and we can check whether this control IC is working fine. So let me connect the adapter first. Okay, the adapter is connected. So on pin number 4 we have the gate voltage for this MOSFET. No voltage. Input voltage, yeah, 3.3 volt is there. Gate voltage, no gate voltage. Yes, no gate voltage. So let me check the input voltage for the controller IC. So that is on pin number 20. So pin number 1, yes, 20 is here. So to this capacitor and you can see this is the resistor, that is 22 ohms resistor, and we need to get 19 volt on this point. So let me check that, and we don't have a voltage there, so the voltage is missing for the controller IC to provide the driver voltage. Okay, so let me check the voltage on the resistor. So before the resistor we are getting 19 volt, and after the resistor we are not getting any voltage. So something is happening here. Maybe the resistor became increased its resistance. So let me check the resistance value of that resistor here. Yeah, and it is around 5 kilo ohms. So actually we should get 22 ohms. This is far more higher than the expected range. Okay, so the next question is, why does this resistor got shorted or increased its resistance value? So basically this resistor will get shorted if the output line after this resistor, for example if this capacitor gone shorted to ground, this resistor will got shorted and increased its resistance, or this IC itself may have gone shorted, and at that time also this resistor will increase its resistance to protect this output, the input line, which is the main power rail. Okay, so let me check whether we are getting any low impedance on the output side of the resistor here. Okay, checking the resistance on the output side. Yes, we have 255 ohms, so that is not far too low, but anyhow, yeah, we are getting around 0.4 diode drop value. Yeah, 256. Okay, so what I'm going to do now, I'm just going to replace this resistor here and check whether we are getting a drive voltage. Okay, okay, so let me check the resistance value of this resistor. Yes, it is 22 ohms, so it is appropriate. Now let me plug in the adapter. Okay, so the adapter is connected. So currently it is drawing around 59 milliamps. So the board is trying to do something, so it is going around 100 milliamps. Let me press the power button. Yes, 800 milliamps this time. Okay, let me check the voltage on the output side of the MOSFET, and we don't have anything. What about on this side? Yeah, here also we don't have anything, but still we have 19.5 volt. So okay, let me check the resistance value back. Yeah, you can see the resistance value has increased to 100 ohms. So the problem is actually with the IC here. So the IC has gone shorted, so that's why it has increased its resistance. So let me replace this IC and check whether we are getting the drive voltage. And I'm sure this capacitor is okay, and if this capacitor gone shorted, I will get the same problem on this resistor here. And I think the problem is actually with the MOSFET here, I mean with the control IC. Let me see after replacing it. Okay, Okay, so now I have replaced the IC here. So before plugging in the adapter, I need to check whether I'm getting a good checkpoint after the resistor here. So before we got 250 ohms, let me check whether we are getting a high ohms or high impedance this time after replacing the IC here. Okay, so checking the resistance value after the resistor here, 10 ohms. So I'm checking with regard to the ground, I'm reading 10 ohms. So after replacing the IC, I'm getting even low resistance. So 22 ohm is okay, right? Yeah, still we are getting 10 ohms. So I think the problem is not with the IC, but with the capacitor there. Okay. I'm sure I have soldered the pins correctly. So the IC is properly soldered. No bridges. Yes. So I think the capacitor is the problem. Okay, so let me just remove it and check once again. Okay, remove that capacitor. Now let me check it once again after the resistor. No, still we are having 10 ohms. So I just got this IC from another motherboard. I think this IC has already gone shorted. Really bad. Okay, because I don't have this IC, brand new IC. So then I need to find a brand new IC and replace it here. Okay, right, so the capacitor is not the problem, actually the IC. Okay, so let me come with a brand new IC so that we can continue the case. Okay, so now I have changed the brand new IC in this motherboard. So now it looks clean. Right. So now let me check the impedance value on the input side of the IC. This time after the resistor. So we have over limit. Okay. Yes. Reverse probing. Yeah, we have around 600, so that is fine, greater than before. Earlier we had around 400, so this is fine. Checking the resistance value of this resistor. Yes, 22 ohms, so that is fine. Okay, now let me plug in the adapter. So look at the ampere reading. Yes, around 10 milliamps. So pressing the power button. Yes, the board has turned on. Wow. So the ampere reading is around 400 milliamps. So I think the board is working fine. So right now this IC is working properly. So let me check whether we are getting a display first. Then we can turn it off and check the requirements of this IC, how it is working. And yes, we got the display, so everything is working fine. So now the ampere reading is around 400 milliamps, so that is fine. So let me turn off the motherboard so that we can check the voltage on this pin here surrounding this IC. Yes, turned off. So we need to check whether we are getting 1.5 times the input voltage on pin number 17. Pin number 17 is this one. So checking the voltage, and we are getting around 29 volt. So that is very, very perfect. So 29.3 volt. And on pin number 13, yeah, on pin number 13 we should get 12 volt. So that is on this side here. Yes, we are getting to a 12.54. So everything is okay. So if I turn on the board, I will get driving voltage on each of these MOSFET. Let me check that as well, and that should be around 12 volt. Yes, so 12.4, that is there. Yes, 12 volt is there. So all of the MOSFETs are working fine, and the IC is also working fine, and we got the display. So okay, so we have the LED also in this motherboard here after replacing this IC. Okay, so that's interesting. But what's the connection between this IC and the power indication on this connector here? Because the EC chip is the only IC or the controller that turns on this light once the adapter is connected. But if the IC is not working, this controller IC, load switch controller IC is not working on this motherboard, then I think this adapter light won't glow. Okay, so one clue we can get, if the IC is faulty on this type of motherboard, then the adapter light won't glow. So if the light doesn't glow, then we can assume that this IC may have gone shorter. So anyhow, let me open the schematics and find if there's any connection between this IC and the adapter light here. Okay, so if you look at pin number 15, so that is the power cord pin of this IC here. So this power cord pin is straightly connected to the AC in signal using this resistor here. However, if you look closer, they are using star symbol, which means this PR121 is not populated in this motherboard, which means there is no connection between power cord pin and AC in signal on this motherboard here. So let me copy the AC in signal so that we can find wherever it goes. Yes. So this is going to the EC chip. So this is not an output signal. So this is an input signal to the EC chip from the charger IC. So charger IC is the only IC that originally initiates the AC in signal from one of its pin. So charger IC will send 3 volt when the adapter is being detected, and this signal also goes to the load switch controller IC. However, in this motherboard they are not connecting the AC in signal to the load switch, so there is no problem with that. And we had 3 volt on the AC in signal while we were checking before, so there is no problem on the AC in line. And if we go to the charger IC, yes, so you can see on pin number 6 the adapter detection pin. So if the voltage is between 2.6 to 3.15, then the charger IC will sense as a valid adapter and it will send 3.3 volt or 3 volt on this pin here on pin number 5. So it will just leave as open drain, then automatically this 6 volt will be divided using these two resistors and we will get 3 volt output. Okay, so there's no problem with that. So the question is, what is the logic behind this one? So only if the IC is installed, or if the IC is not working on this motherboard, then we are not getting the adapter light. So what would be the logic behind this one? So if you look at pin number 13, so that is 12 volt always output from this IC, and this 12 volt always output will be present only when this IC is working properly. So if I copy this signal, wait a minute, yes, if I copy this signal, not important, yes, not important, and yes. So if you look at this one is the DC in connector, so this is the DC jack, and we have two LEDs here. So the 12 volt always voltage is going into these two MOSFETs, these two N-channel MOSFETs, 2N7002. 12 volt always is going to the gate of this MOSFET. So when an N-channel receives a higher voltage with respect to source, then it will conduct both sides. So this will be connected together and this will be connected together. So we will get a positive voltage on the positive end of the LED, and the negative end is already connected to the ground, so the LED will glow. However, the EC chip takes the control of turning on each of these LEDs using these two NPN transistors. Okay, so if you look at this transistor here, the arrow pointing is outwards. So if the arrow pointing is outwards, it is the NPN transistor, NPN transistor. And if the arrow is pointing inwards, that is PNP transistor. Okay, so in this case, this is an NPN transistor. Okay, so for the NPN transistor, we need to provide a higher voltage or positive voltage on the base point in order to conduct the emitter to the collector, or in order to pass the energy from the emitter to the collector. So if we are getting a high voltage or positive voltage on the base of this point, then the ground will be passed to this point here. And if we are getting a ground or low impedance on this point, then the N-channel MOSFET will not switch the voltage from 5 volt, switch the voltage of 5 volt to this side here, and eventually we will get a 0 volt for the LED on the positive side, and it will not glow. So in order for the LED of the AC LED to glow, we need to get 0 volt, which means you can see hash symbol, which means we need to get 0 volt or low logic on this pin. And when we receive the low logic, the NPN transistor will separate the emitter and collector, or else there won't be any low impedance at the gate of this MOSFET, and the 12 volt always voltage will straightly go into the gate of the voltage, and it will conduct 5 volt to this side here. So then the LED will glow. Also, the same principle is being applied on this point here. So if the battery is charging, the EC chip will use this MOSFET and this transistor and this MOSFET to control the battery LED. So based on that, the EC chip will control both of these LEDs. So if the 12 volt is not present on this motherboard here, so we will not get a gate voltage for both of these N-channel MOSFET, and they will not switch 5 volt always to this point here to provide the positive voltage for the LED, and the LED won't glow because they don't have a positive voltage. So in this motherboard, that controller IC is also needed, and the EC chip also needed. So both of these IC play a critical role in turning on the LED, and any one of these IC is not working properly, then the LED won't glow properly. Okay, so this is how the LED circuits works, and we need to have 12 volt always in this motherboard, always, in order to produce the LED light on this DC jack here. Okay, also I wanted to say some interesting thing about this circuit here. So if you look at PQ16 and PQ5, so this confirms that EC is the master in this circuit here. So if the EC detects that the adapter is not validated, or if there's a problem on the adapter, or if the charging is going to be disabled, then it will send directly a high impedance on this point, which means a high voltage. At that time, the NPN transistor will shift the ground to this point here. Even though we don't have, or we have 12 volt always voltage on this point, still we will not get a positive voltage to the LEDs. So the master in this circuit is actually the EC chip, not the controller IC here. So in this case, the EC chip is not actually sending a high voltage on PQ16 and PQ15. The only problem is the controller IC is not sending the 12 volt always voltage. So that is the main problem here. But if the EC is sending a high voltage on this NPN transistors, even though we have a voltage on this point, and if the MOSFET switches these lines together, we will not get a positive voltage on this point because this NPN transistor is now sending a ground or low impedance on this lines here. So a positive voltage will not come to the low impedance point or to a ground point. So at that time your LED won't glow. So EC takes the biggest control in controlling these LEDs here. Right, so now let me just assemble this inside the laptop and see whether we are getting a display. Okay, so everything is assembled inside the laptop. So let me connect the adapter and go for a last check. So the battery is also connected. So let's see whether the battery is charging. Yes, connected. So 100 milliamps. So it's a pre-charge current. Yes, 1.5 ampere. And now the battery should be charging. So still I did not press the power button. So you can see now the battery is charging fine. So it is drawing around 1.5 amps. So now let me press the power button and see whether the board is turning on. Okay. Yes, the power LED is blinking and the board has turned on. So the laptop is working fine and we got the display. Okay, let me show you that. So the hard drive is not installed here, so I'll just show you the BIOS menu. Yes, so everything is working fine. So there's no problem. Okay. So I'm glad that I was able to fix this one. So thanks for watching guys and see you later in a new video. So I hope this video is useful to you guys. So good luck.